I welcome you to my another video about electrician's tools. After some reviews about multimeters for general DIY hobby use, let's talk about something more serious, or rather more advanced, something you can rely on even in more or less professional field and entry-level industrial, just more high-tech use. For this video I bought 3 multimeters for main review. They all have common basic accuracy of 0.05% for DCV measurement. For comparison, general use multimeters or DMMs have basic accuracy of 0.5%. So we are talking something that is 10 times more accurate than what we are used to. These participants include Aneng AN871 for $40, then Owon B41T Plus for $70, and UNI-T UT61E Plus or 161E based on market for $125. I also decided to add general use DMM, not just for fun, but for comparison to see in reality where the differences are. The example for not direct comparison was chosen to be Kaiweet's HD118A for $36. All my other DMMs are either older, like my M probe, so their accuracy may have shifted and their technology is somehow obsolete, or they are from different category, like these DT830 series that are the bare minimum that can be at least turned on and used. This particular piece has shown that it meets specified 0.5% accuracy with freaking huge reserve. Why do accuracy concerns? Well, for most jobs you are fine with 0.5%, but if you need to calculate some data from primary values that are measured with DMM, you need them to have as reliable values as possible. Inaccurate primary data may lead to constructive interference of errors and then spit out absolutely wrong output that may lead to your misjudgment. For example, if you, let's say, fine-tune something like DC converter and need best efficiency, even small differences make sense and need to be captured. If errors of both volt and ammeters on both input and output would have constructive errors, results may have even error of 2% and may create false image, because regarding efficiency we are talking about differences like 95% versus 94%. Moreover, the more accurate your test is, the easier it is to later add some data and compare them directly, even if you use different DMMs and different technology. Please note, we will keep ourselves in waters of reasonable solutions for home electronic laboratory. There will be no such things like, for example, table multimeter Keysight 3458A for like $13,000. First, let's tell a fairy tale of my main DMM. Every electrician has his most favorite DMM he just likes to use most often. I began with cheap DT830 series, just like this one. Back then they weren't that bad, but still inaccurate, slow and unreliable. I was just a little boy bending his first wires. Then it broke and I managed to find analog multimeter Metra PU500. It was made in Czechoslovakia, today it's Czech Republic. The multimeter had horrible accuracy, even worse than what is usual for analogs. For example, these Avomets, also from Czechoslovakia, former Czechoslovakia, were way better, but they didn't have ohms measurements. Then it was gray Metex. These were high-tech and eager to die. Many ranges you can see have died, and I will tell you they died without any reasons. So did this yellow one. I even changed whole microcontroller. It just doesn't work. Then my father got me this M probe AM530 €. M probe is like cheaper Fluke, I believe. It has served quite reliably, but it is slow as hell and its accuracy is just 0.8%, which is not good. Then I bought Aneng AN870 and used it for a while. It was quite a good as main multimeter, but the quality, well, I wanted to make a video about the Aneng, but I wouldn't recommend it, so that's why I bought 2 more multimeters for the testing range. Regarding the table, subjective feelings are subject to huge error. May it be just lack of feel in some way, or just basic human-like behavior of liking one and finding most reasons why this one is best. Such table with reliable measured parameters is objective and leads everyone to his own conclusion based on his requirement. These are values and points of them. The points are, however, a bit subjective because I gave them priority by determining the range of points given. Now for voltage. I have a reference source for that. It has accuracy of 0.05%, but in practice it is more exact. It is powered by zinc carbon batteries because batteries have almost no noise. There are 4 voltage measurements and I calculated both error from value / error from range. Error from value is important to us, but error from range is more multimeter related. For example, if you measured 1.5 volt battery on 1000 volt range, you still have same range accuracy but awful value accuracy. Value accuracy is always worse than range accuracy. Accuracy of error that is written in manual is always from range, plus number of digits that can vary, but it isn't that much important to us if we don't have long display that could display us phone number. All 3 multimeters should have 0.05% precision at normal voltage ranges, but these are guaranteed just after you buy them. Some manufacturers also mention how worse it can happen after a month and a year, but this is world of more precise and expensive laboratory equipment. These multimeters don't count as such. UNI-T has shown exceptional accuracy and its error can fit 5 times into the specs. Awesome reserve. Let's hope it won't get worse after time. Owon is somehow non-linear and it can fit 2 times in its specs. That's quite as usual reserve. Aneng, it is 2.5 times worse than what does manufacturer specify. My friend, who is admin of Electrolab webpage, also had one Aneng for review, and his piece, however, did fit into its accuracy specifications, although there was no reserve. I think these Anengs are not factory calibrated properly, or their key components are low quality. To be honest, 0.13% error is globally not bad at all, but it should have been more than 2 times nicer. Kaibe's multimeter, it is rocking as hell, as it meets 0.02% accuracy, real accuracy from range, even if the specified is 0.5%. This multimeter is 25 times better accuracy than what does manufacturers say. Personally, I think it's rather a coincidence than rule. I'm pretty sure that other pieces would have worse error, but hey, this particular piece can even be used as laboratory equipment, as long as I of course keep calibrating it, or more precisely checking its accuracy periodically. So really awesome reserve in the specs. Current comparison. Firstly, let's address clamp meters. Clamp meters are great for only higher currents. They quite detect hundreds of milliamps, but amps is the lowest value we can trust. Clamping a meter also does not require us to make invasive changes to circuit, as there is no need to disconnect the way of current. On the other hand, if we want to measure current precisely, we need go through a meter. We can usually measure from microamps to 10 or 20 amps. Beware, you can't run over 10 amps for a longer period of time. We will shortly see why. All the meters should have 0.5% precision for currents. UNI-T fits in 16 volt. That is absolutely fantastic. Owon fits in 6 times. That is perfect. But Aneng, we can trust it only up to 10 amps. Kivets may not have huge reserve, but it also meets its specs. Now, why we can't run higher currents through our multimeters for longer time? In this mode of measurement, amp hole and COM hole, they are both shorted. They are connected through fuse and through shunt resistor. Fuse is there for safety. The shunt resistors puts Ohm's law in use. When current passes through it, it generates voltage difference on the shunt. This voltage is then measured by the actual DMM and calculated into amperes based on known shunt resistor's resistance. However, if there is voltage present on it and current is passing through it, there must also be heat generated because there is power on it. Like if you, for example, overload wires, right? I calculated that in Aneng, the shunt resistor generates 14 watts of thermal power if 20 amperes would pass through it. That is huge value. Aneng is made for 10 amperes max, but somehow they rated it 20 amps and don't write any warnings. The glowing red shunt resistor not only can desolder itself from the PCB or cause heat damage to plastics and PCB, but also the resistance of the shunt increases with the temperature, so the multimeter measures more and even more millivolts on the shunt, while the current remains constant. That is why I also tested the multimeters for shunt overheating, that is this line. I let 90% of nominal current pass through them for 1 minute. This is far beyond specs of both UNI-T and Owon, as these smart manufacturers actually warn about shunt overheat. UNI-T has thermal overheat alarm, for example. Moreover, there was lower heating power in both UNI-T and Owon because their shunts have about 20 milliohms. So both UNI-T and Owon are good for 20 amps for, let's say, maximum 1 minute. And UNI-T also compensates the temperature. Aneng has same resistance as temp amp rated kVts, so don't be angry at me, but I must say that Aneng can't ever be used above 10 amps. Not only it grows majestic error, but it would also melt. Now about smaller currents. UNI-T is the best. Period. What makes measuring instrument or measuring process good? I mean in general. The measurement should not affect measured object. If we affect reality by measuring it, our data is practically useless. UNI-T has beautiful low current shunt resistance of 320 milliohms. 1/3 of ohm would not affect any low current circuit because voltage drop on the meter would be 64 millivolts at maximum current of 200 amperes. 64 millivolts is nothing. By the way, the wrench is actually fused 1 amp, but it can't measure that high and shows overload. I think that's because of inrush current. This DMM should withstand quite an inrush. These 64 millivolts are nothing in most cases. Other DMMs have significantly bigger resistance. For example, voltage drop on this kVts is 2.8 volts at 600 milliamps. That is maximum current for the milliamp range. 2.8 volts difference? Well, good luck. You must compensate for that, which is difficult sometimes. However, both Owon and Aneng disconnect the milliamp from COM if you switch the rotary switch to another range or another function. So it is safer. For example, if you forget your leads in milliamp hole and go measure voltage, it actually disconnects. Parameters comparison. Input resistance is about 10 mega ohms. That is usual. Only UNI-T has 1 giga ohm at millivolt DC range. That is beautiful. UNI-T also has semi-automatic AC-DC volt mode, as you can switch to it if you go like this, and then you can activate the automatic mode by pressing select. It then automatically detects whether the voltage that is present on the holes is AC or DC. UNI-T also offers low pass filter that can be enabled with this button. This is low pass filter, so it filters out higher harmonics or higher frequencies. Kaiwitz, for example, has dual display and shows both AC voltage and frequency. Now, regarding continuity, resistance and diodes, both UNI-T and Aneng beep below 50 ohms. UNI-T also lights up LED up to 230 ohms, like resistance of a coil, for example. Owon and Kaiwitz beep below 30 ohms, but Kaiwitz also lights up the LED below 60 ohms. Beeping delay and reactions are crucial for any multimeter. We will show it. If your DMM doesn't beep instantly and loud, it is useless. UNI-T and Aneng are the fastest, as if it was like classic analog beeper. Owon has tiny delay and Kaiwitz a little delay too, but it also interrupts beeping for range switching. Then we have diodes, voltage and current, and speed of capacity measurement. NCV or non-contact voltage detection, UNI-T may have up to 5 levels, which is the highest number of course, but the sensitivity of NCV is so poor that you better forget about this function entirely. You would have to throw it near 110 kilovolt power lines to trigger its NCV. It is just so insensitive. It is because the multimeter has inner shielding. Aneng is best in NCV and Kaiwitz quite good. Owon has no NCV, so practically like UNI-T. Now let's test our beeping. UNI-T has gilded probes, perfect, and its reactions are astounding. Absolutely perfect. You can't see the LED. Perfect, perfect. Now the Owon. A little slow. But useful. Aneng. Just like UNI-T. Kaiwitz. Quite good, but it interrupts for range switch. Readability of UNI-T display is excellent from any angle, just like Aneng or Kaiwitz. Owon is pretty bad. Both UNI-T and Kaiwitz have homogeneous backlight, sign of quality, but Kaiwitz is much brighter. All multimeters have similar display counts, only Kaiwitz is primary general purpose DMM and the precision is more or less about luck, so the 6000 counts should count as good too. Actually, Aneng and Kaiwitz should interchange the displays between them, that would suit both meters better. Kaiwitz also doesn't have a range button. Its presence would be needed even more since this is the slowest DMM of this comparison. Bar graph, it is the thing that hammered the last nail in analog multimeter's coffin, and of course it does better than analog, at least UNI-T and Owon, as we can see, with their 30 updates per second. They are fluent like a film and faster than hand of any analog meter. Kaiwitz may have bar graph too, but it doesn't have separate ADC, so it takes values from primary integration ADC that has approximately 3 readings per second. If UNI-T and Owon were like a film, this is like a moving GIF picture. Such useless bar graphs are common in cheap multimeters. Speed of measurement, it was rising slope from 0 to 10 volts. Owon is the fastest, then came UNI-T and Aneng, and Kaiwitz is the slowest. Needless to say that 10 years ago multimeters for such prices required you to wait for 2 seconds until they finish integration of the value. Power comparison. Let's talk about power. If any of them had 9 volt blocks, I would personally give it minus 100 points. Oh god, how I hate 9 volt batteries. Fortunately, everything is okay. UNI-T has 4 AAAs and others have two AA's. At first glance it would seem that two AA's are better, but there is one problem. Microcontrollers and other things inside require some minimum voltage under which they stop working. We'll talk about it later. Standby power consumption is minimal with kVs and Aneng. Owon has double the consumption and UNI-T tenfold the consumption. UNI-T also has most precise ADC, so it may be because of this. Let's compare battery life. Let's assume 1 amp hour for AAA's and 2.4 amp hours for AA's. Aneng and kVs last 2 months of constant use. Owon lasts 1 month of constant use without Bluetooth. And UNI-T just 4 days. What the heck? 4 days of constant runtime? Ain't that a little too short? Yes, it is. But let's look at voltages. While any other multimeter power off at approximately 1 to 1.2 volt, which means you must power them with alkaline, zinc carbon, primary lithium, which are expensive as hell, or nickel zinc batteries, UNI-T turns off at 0.89 volts, which is absolutely compatible with rechargeable nickel metal hydride batteries. So yes, you will have to open it more often, but hey, just use rechargeables. Buy these Panasonic Eneloop Pro or IKEA Lada. That is almost the same thing and you are safe for next, let's say, 15 years. Physical comparison. UNI-T has great mode selector, exact positions, nice clicking, big handle and rubber overmolding. It can be operated with thumb easily. It sticks to table nicely, and if we use the leg, nothing changes. Even buttons don't make it unstable. It is highly ergonomic, and it also has thread for tripod and lead holder. Absolutely industrial quality. Owon has more plastic clicking, and unfortunately when you hit a rotation the knob vibrates to your fingers. It is also sharper to your fingers. It is unable to be operated with thumb. Ow. No, it holds in place while switching, and elevating the leg shows us its worse quality, and it slides a little when switching. However, buttons are okay. Aneng has even sharper switching, and the handle is really small and really sharp, not comfortable. Leg, well, it should better have no leg, because I don't call this leg. This is just laughing in the faces of people who need leg. You need flathead screwdriver to open it. It's wobbly, it's flimsy, and it's shitty. Forget about switching selector or pushing buttons. Are you serious, Aneng? Are you serious? Look, now I can press it, and now I can't press it. Go away. kVs has softest switching and can be really easily operated with just your thumb. But the selector has a little play. Leg is much better than Owon and slightly worse than UNI-T, so actually great for Chinese multimeter. Switching on the leg is absolutely okay, but buttons, forget about them. The buttons are very hard to press, as you can see and hear. Most probable cause is that this multimeter is for harsh environments and to be operated in gloves. These buttons, however, have clear press. Both Aneng and kVs have to be stripped from their case to change fuse, and believe me, I have never disassembled any multimeter that would be harder to open than kVs. The rubber is hard and everywhere around. Let's open them. UNI-T is the only one here where you can change fuses without opening whole multimeter. Unfortunately, these are British type fuses. They are 1/4 by 1 inch or 6.3 by 25.4 millimeters. Hard to find them in Europe. I had to order them for Farnell. Aliexpress may offer fuse sets, but who would trust Aliexpress fuses? Me not, believe me, I have my experience. Plus minus approximately 1500% of nominal current. Now, regarding the UNI-T, we have a really beautiful multimeter. These holes are actually made of one solid material. I don't know if it is visible or not, and the material is held by screw to these tabs. Then we have 4 PTCs, 3 varistors and some diodes to protect the amperes. Then we have springy contact for shielding. The shielding is present here, and I think it is the only thing that is responsible for the NCV not working properly. Then we have our communication diodes, RX, TX, I don't know which one is which, and springy battery contacts. Owon is a little worse. Here is the shunt that is calibrated by a blob of tin, but the fuses are only 5 by 20, so they are the cheapest fuses with fairly low breaking capacity. The holes are, well, okay, and there are just 4 small PTCs and some tiny diodes. Battery contacts are on the PCB, which is not that great, as they may sometimes get broken. This is Bluetooth module, so it can communicate via Bluetooth. This multimeter is Aneng. It has 6 by 32 millimeters fuses, which are great, quite great, but guess what? There is no overvoltage protection, just these resistors, that's all. And this PTC, I don't know whether it's there for protection or something else. So Aneng is a really bad multimeter. Please don't mention this white thing. It's actually silicone. I tried gluing a heatsink on the shunt resistor to decrease its heating up and the error, but I had to, of course, put it out of the multimeter for measurements. Holes are, well, quite shitty. This is Kaiwitz. It's a little better, even though the Kaiwitz is actually cheaper than the Aneng. We have same fuses, but we also have some basic protection. Just for comparison, I have here M-Probe AM530 EUR. This is industrial grade multimeter. It has PTC, 3 varistors, PV10 fuse and 6 by 32 fuse, some diodes, and that's that. So even if this multimeter is quite old, it is great. I would assume that these 2 multimeters are the bestest of all of them regarding safety and how well they are made inside. Packages. Original UNI-T probes are near perfect. Personally, I prefer these ultra sharp needle ones, but they are easy to bend and easy to break, so this is definitely super. Moreover, they are gilded, so they have perfect contact. There is also adapter for transistors. Well, screw them. All I need is temp measurement. Then there is also USB adapter, and the PC software is easy to control. It shows graph, records data, and can even control the multimeter. Owon may have screwable crocodiles, but the leads are rather bad. K-probe is ordinary. Adapter is, well, okay for some K-probes with these contacts, but beware, this paper says accuracy of 0.1%, while manufacturer claims it to have 0.05%. Owon also has one invisible function, and it is Bluetooth. You can connect it to your phone or computer and take data, control the multimeter, and even set it for offline data logging. What is really annoying is the fact that when you turn on the backlight, you also activate hold. this problem is just software problem. This is how you activate hold, just short press, as usual. Now you want to turn the backlight on. You long press, and the hold is still there. You have to press the hold one more time. Now you want your battery to last longer, you turn it off, and the hold is again. So this is a huge problem, and they didn't thought this out. Now for Aneng. Well, this is actually nice. We get standard leads, quite sturdy ones. Then we get modular leads with lots of endings, any different endings for these screwing leads. So this is really great if you do just some basic DIY things. You have everything you need here. And then you get really beautiful K-probes. You can stick it into a cookie, for example. K-leads only had regular leads, regular K-probe, if I remember correctly, but it has nice features like one lead live wire detection, and it has LED indicator just like UNI-T, and it also blinks holes we should use, which is great for beginners. Let's sum it up. By my subjective points, the UNI-T has won with awesome 101 points. Owon has nice 68 points. K-leads, that was just for picture, reached 44, and Aneng only poor 17. Personally, I think UNI-T has made a huge jump forward, and they do pretty well. This video is paid for by my channel members and people without adblock on my main Czech-spoken YouTube channel Jiří Becker that currently has somewhat over 15,000 subscribers. This English channel is just parallel and has only few videos translated because it takes quite much time to make videos in 2 languages. However, if a topic is useful and also for global, then I record it in both languages, but it takes more time. That's all for this video. I hope you can choose your budget precision multimeter based on your personal preferences, and goodbye.